Hi, this is Aaron with iBoard Repair, and today I'm working on an iPhone SE second generation, and it has one of the most signature problems possible for this model. If I bring open the panic log, and if this focuses, missing sensor mic 1, right there. And there we go, the phone has also restarted. So that's what the problem is. That's what the signature problem is on this model. It has a motherboard problem where certain lines get disconnected, certain traces get disconnected, and I'll have to be manually reconnecting those in this video. It's a kind of a complex situation, so I'll show you what I have going on. So with my iPhone SE2 board view software open, I can show the traces on the first layer here. And these three are the problem right here. Two of them are the mic 1 sensor, the I2C1 APS-CL and the I2C1 APS-DA. And then the third one is a touch line, and this one also commonly breaks, but in this case we have touch working on this device. These traces, they go over to the charge port here, and they don't allow the CPU to talk to the mic 1 sensor on the charge port. And without communication from that sensor, the iPhone will reboot every 3 minutes. So on our FPC connector, it's going to be these two lines right here that are giving me the problem. And what actually happens, we think, is flexion on this board breaks the traces underneath this SIM card tray here. So we can tap into the line on the other side of the SIM tray. We can connect a jumper to these points and run them all the way to where they're supposed to go at these capacitors, and that will reconnect the line for us and allow the CPU to talk to the mic 1 sensor again. And it is usually worth it to actually also just repair the touch line when you have this problem, because if these two lines broke, this third line is usually going to be followed shortly after. So the reason we would tap into the line at this point is normally just for the touch line, because the touch line actually has no other place we can tap into it at. It goes directly underneath the CPU, so we'd have to lift the CPU in order to do that, and that's just not feasible. But the mic 1 lines, they actually do have a resistor that we can jump to. We have one here, and the other one is over here. So on this repair, I think the easiest way to do it is I'm going to run the mic 1 jumpers to the resistors, and then I'll just tap into the touch line on its own right here. And I'll just do that preemptively, because almost surely this phone will come back for warranty if I don't do that. And now I'll just go ahead and I'll take this phone apart and we can get started. So I've got this logic board out of the housing, and let's double check those lines with the multimeter at this FPC connector just to double check the problem. And if I measure that, 1, 2, 3, 4, 5, 6, 7, I do get a reading there, 0.35, 8.33. I do actually get a reading there as well. 1, 2, 3, 4, 5, 6, 7. So there we go. We're seeing a jumping measurement here. That one seems stable. But this one here, there we go. If I push on the SIM tray, or if I kind of just have different sorts of pressure, this line is jumping. So that's how you know that this one is the one that's partially disconnected. That's what's tricky about this problem. A lot of the times the measurements will seem kind of normal until you really dig into it a little harder. There it is. It's not supposed to be that high. It's supposed to be, that 0.36. So I'll get started. I'm going to go ahead and run the touch line first over here. Then I'll run the mic lines on top of it afterwards this way. And I'll kind of just layer them on top of each other with solder mask. So again, only one of these lines was really measuring bad, in my opinion. The one that was showing inconsistent measurements. But all three of the lines are worth fixing, because the problem is very prevalent, and and it will surely show up later on down the line, and this will come back for warranty if I don't fix it now. And it looks like somebody already tried to flip this CPU in order to fix this problem. Nah, I'm just kidding. But this one is upside down, and I think it's funny when sometimes this RAM chip is upside down on here. I don't know why that is. So if we were paying close attention, we were able to see the line comes right around the top of this this solder here, the solder pad here. You can see it's right here. Here's that solder pad, and it comes right through it. So trace repair can be quite brutal. This is as close as I can get with my Barlow lens on. And when you're working on traces, you want to get even closer, even more zoomed in than this is. So I'm going to remove my Barlow lens, and I'll get an even better zoom on here. So now we can zoom all the way down into here. And that extra vision is really going to help here. The trade-off for this extra zoom is a lot less working distance underneath the microscope. And you can see we don't have a lot of area right here, so it gets a little bit hard to actually scrape properly, but I'll give it my best shot. I do lose focus quite a bit easier when I'm this zoomed in as well. Just putting the pressure of my fingers on this board and pressing down takes me out of focus a bit. The sharper the razor blade, the better when you're scraping away layers of your motherboard. And if you add a little alcohol, it gives you a lot clearer vision when you're looking through. So I can see that bottom trace there. And the one I'm looking for is the upper one. I'll turn the fume extractor back on just because I'm using this alcohol, and I'll be soldering soon. That should be enough clearance. And there we go. That's probably enough space, but let's see if I can give myself a little bit more room. There we go. I'm pretty happy with that. So let's see if I can tin that. When things get this small, it's really easy for the smallest shakes to become a problem, so I like to kind of stabilize by grabbing the iron tip with a pair of tweezers with the other hand. I'm not really happy with that. I'm going to try to get a bit more solder on there. It's hard to get solder directly on the smallest part of this tip as well. And so my normal iron temperature is 350, but when I'm putting down solder that I want to stick, I usually drop that a little bit, so I bring it down to 300. That looks a lot better. I have a blob on there. It might be hard to see. But yeah, there's a nice blob on there now. I would have liked it to be spread a little bit further, but I think it's okay. I think I will try to extend that blob of solder just so it's a little bit more even. There we go, that looks much better. And I have some 0.009 millimeter wire here. That's what I like to use for this job. And you can see even with wire this small, it's still relatively bigger than the trace. And it might have been better to use insulated wire, but the insulated wire can be a bit harder to work with if you don't burn away the insulation. And I'm not sure if they make insulated wire that's actually this small. Most of the insulated wire is 0.01 millimeters, not 0.009. But yeah, if we zoom out, take a look at how small those traces are. That's pretty crazy, isn't it? That's not too bad. Yeah, that looks like a fairly solid connection to me. What I'll do now is I'm gonna clean this a bit, and then I'm gonna tack it down right here, and then I'm going to tack it down all the way around. I'm not sure exactly the way I'll route it, all the way to where it's going over here. And again, this first line is the touch line, and I'm doing this preemptively. Again, I don't have a touch problem on this board yet, but with that first line broken, usually these other two break along with it at some point in the future. So I'm doing this to avoid warranty work later that I'm sure would come back, or at least there's a 90% chance it would. Yeah, that looks like a very solid connection to me. So I think I'll just tack it down like that first. And you kind of just wanted to make sure you have the solder mask underneath that wire too. You don't want this to touch the ground that's right next to it. I don't know if I can get a measurement on this wire, but I'm going to try to make sure it's not ground right now. There we go. And yeah, it looks like I got a good reading. Well, it's not ground. It's not stable because this is not a very stable connection here. It's hard for me to pin it down, but good enough. So I'll tack that down right there, and I'll tack down the rest of it once that's dry. So I'll give it some UV, and once that's cured, I'll go ahead and run the line further down. Okay, that should be good enough. And now I can run this line further. Okay, I think that's probably as flat as I'll be able to get it. So I'll do another section of it, and then I'll probably run it to the end after this one. I might have to do one more partial tack first. We'll just see what happens. It's probably as much as I want to do now, just so it doesn't come up too much and just mess up my work so far. Alright, that looks pretty good. At this point, I think I'll just attach the wire and then solder mask it all the way down. One, two, three, four, five, six, seven, the 8th pin, and the capacitor directly in front of it. Or 2 pins over from ground. Yeah, there's also a gap right here, so it's this capacitor that we're going to want to connect to. And I can actually take a reading on that capacitor right now just to make sure my line isn't short to ground. Yep, and it's still normal. So I'll tin that cap a little bit and attach the wire. Something like that will probably be okay, about right there. That will give me just a little room to adjust that wire. I think I'll just go ahead and cut this wire right at this spot as well. That looks pretty good. I do think I want to touch up that solder pad just a bit, make sure it's as sturdy as possible. Let's hope I don't mess it up by doing this. There we go. That looks a lot better to me. So now I'll just tack this line down as the last one, and the next two jumpers will be a bit easier. And the line looks great. I'll just go ahead and make sure it's not short, that the measurement is good before I give it the final UV blast. It looks good. So I'll let this line cure, and then we'll move on to the mic lines. Just to be safe, I'll add a little bit more by this battery connector here. Alright, we're looking good so far. Let's get these last two jumpers on there and route them where they need to go. I'll do the farther one first, so the 8th. I'll lay that down on top, and then I'll lay down the 8th pin, I should say, and then the 7th will go after that. 6, 7, 8. So let me see where this connects to exactly. So the capacitor right in front of it on both cases. So 1, 2, 3, 4, 5, 6, 7. The 7th cap and the 6th cap. So I think in this case I'll use a little bit of a bigger and an insulated wire, as I don't actually have to dig into the trace in this case. I'll go from here to all the way up here. So I'll tin this one first. So that was right here. And right here. And both of them are just the inside point that needs to be connected to. And that first one is going all the way up to this very first resistor right after the cap. So we go into right here. Okay, I have some insulated wire here. And I just take this from speakers actually. If you take an iPhone speaker and just crack it all the way open, it's going to have one of these coils of wire inside. And these are insulated. And they're a little bit bigger. They're not the .009 millimeters. They're either .01 or .02. I'm not exactly sure. So I'll need quite a lot of this wire. This is a huge and long jumper. So I like to uncoil it first, because if you're uncoiling it while it's soldered, there's a chance that it will break. I'm almost tempted to use the other wire because how many bends are in this one is going to be hard to straighten. Do you see what I mean? I think I will. I think I'm just going to use the other wire because that wire has too many kinks in it. This wire is a bit more fragile, but as long as I solder mask it all, then it shouldn't really matter. It's a nice solid jumper. And that right there is looking really great, so I'll try to leave it like that and tack it down as much as I can. The line's looking really good. The only thing I really need to double check is that my diode mode measurement is still good. 1, 2, 3, 4, 5, 6, 7, 8. And that's good. I think I'll try to attach this wire and do the last bit of solder mask all in one go, because it takes quite a while for that to cure. There we go, looking good. So I will mask this one down now, and then we'll do the last one. I also want to clean up this little bit of misplaced solder mask, just because I like it to look nice. That's really the only reason. It doesn't matter if it's there, but this repair looks real nice when you do it right, so might as well keep it nice. So one last measurement before I set this down all the way. And it looks pretty good. Okay, so I'll blast this with UV again, and then we'll be done with the second jumper and have one last one to do. It wouldn't be one of my videos if I didn't have a small audio problem. So that's my unsteady line. It's still not connected yet, which is why it's still unsteady. That one's good. I'm glad to see the two lines aren't accidentally touching each other. So I'll go ahead and put this last part down now. Or not last part, but almost last part. I think I'll take it out of that little solder pad groove, because that might be why I got a ground reading a couple of times. And there we go, looking good. I'll measure to make sure I'm not connected to ground, and then I will solder mask that. There we go, looks good. Looks good. So another blast of UV, second to the last one, and then I'll be finished after the next. Alright, this repair has taken too long, but we are at the home stretch now. I believe this is the one. Yes, it is. So let's attach to there and then mask it one final time. And then we'll test the device and everything should be good. I'll take a measurement on that line. I believe it should be 0.34. Yep, looks good. So I'll tin that line and then attach the jumper. I think I'll try to add a bit more solder onto that one. Just don't want it to come loose. That looks a lot better. And we're all attached finally. Last bit of solder mask and this is finished up. So especially when I'm working with jumpers that I don't want to mess up, I use flux remover. That way I don't have to brush the the wire. Because brushing the wire can be a bit too destructive for the 0.009 millimeter wires. It can easily snag it and break it, and that would be quite a shame at this stage. The flux remover just will allow me to blow away the flux. And I'll take one last measurement before I give it the final UV blast. And now it should no longer be unsteady. I should have a steady reading on that line since it's fully reconnected now. There we go. Looks good. And when this is finished curing, I'll go ahead and test everything and make sure that we're all good. So, we are finished. And it's quite a long job, but you know, I think it went well, and this phone should be working normally. So I'll go ahead and put it in the housing now, and I'll run a 3-minute timer, and I'll just make sure it's booting. So I'll run a timer now, and we'll just make sure it doesn't reboot. And there we go. And there we go. So I'll put that all the way together right now, but that's the process to fix a iPhone SE2 second generation that is randomly rebooting. It's normally a 3-minute reboot, but it's basically always a 3-minute reboot. So I hope you enjoyed watching this video, and I hope you stop by again. Hope you learned something. Thanks. Bye-bye.